Hello, this is Mr. Gilmore with the 10.9 circle area lesson. So you know the area form of a circle is pi r squared, but how, right? We're going to learn why we know the area of the circle is this today. Where we begin is with our adventure as far as what we have accomplished up to this point in time in our area system. So if I were to give you something that looks very complex like this, it's actually quite simple now to actually tackle this monstrosity below. Because if I asked you to find the area, well, then simply put, you would then be looking at how could we chop that thing up into shapes that we do know the area of, and then go about finding the area of those chopped up shapes. And so if we look back over our chapter, we've seen, we started with squares and rectangles, parallelograms, triangles, trapezoids, rhombuses, kites. All of these things are pointy, right? Just like our complex figure below here. It's pointy. So then my follow-up question to this would be, how would you handle this, right? How would you handle this roundy, right? This round thing. No matter what we do, how we chop it, we're always going to end up with some curved part, some round part, right? Some portion of the circle's circumference, some arc involved in our shape. So how do we go about then finding the area of it? Well, as it turns out, how we're going to get to the area of our circle, this round thing, is actually through the area formula of the regular polygon. So let me remind you of the area of the regular polygon that we saw in our previous lesson. The area of our regular polygon is one half the length, or say one half the value of the perimeter times the length of the apothem. So P stands for perimeter and A stands for apothem. So as it turns out, we're going to be using this to stalk the area of our circle. So really where we're going to approach today, what we're going to find today, is taking the area of that regular polygon, the area of one half perimeter times the apothem, and we're going to turn it into area equals pi r squared, which is actually then in terms of our circle, with r being the length of the radius of our circle. So how do we get there, right? How are we going to transform our regular polygon area into the area of a circle? So we begin by inscribing a regular polygon in a circle. This is where our adventure starts, with our very first regular polygon that we can inscribe, the regular triangle. When we inscribe it, you'll notice that we are beginning to cover up the area on the interior of our circle, but not all of it, right? We still have quite a good amount of area not covered by this regular triangle. But the thing is, if we're given the information about this regular triangle, we can find the area of that, which means we are going to begin to find the area on the inside of this round thing. So what do we then do with this? Well, let's then increase the number of sides. Let's add another side to our regular triangle, make it a regular quadrilateral this time. So we've got a square now. And with a square, we see, oh, that area that then surrounds the polygon and is in between the circle and the regular polygon is getting less. So our strategy begins to work, where what we're going to slowly do is we're going to keep increasing the number of sides of our regular polygon until, let's skip ahead a lot, we then essentially grow closer and closer to filling the entire area of our circle. That's a 10,000 sided polygon. And by our eye, we can't really tell where those side links start and where the circle ends. But we know that if we zoomed in, then there would still be some space between the side of our little polygon and the arc of the circle there. But we're beginning to see a pattern that we notice as we begin inscribing the number of sides inside of our regular polygon here, to increase those, right? And so what we're going to do with those sides is never stop. We're never going to stop adding sides. And as we never stop adding sides, the area of our regular polygon grows closer and closer and closer and closer to the area of our circle. So from our geometric point of view, we see that as we increase the number of sides of our polygon, we get closer and closer to filling and finding the area of our circle. So from the geometric point, that's what we're essentially doing, is we're approaching our area of the circle. So then what do we see as we approach the algebraic point of view? Well, the arrow we see down below grows ever closer to, which means we can actually take, as we saw that the perimeter of our regular polygon, it actually slowly and slowly transforms to get closer and closer to the circumference of our circle. And the apothem of the regular polygon grows closer and closer and closer to become the same length as the radius of our circle. In other words, we can put the area of our regular polygon in terms of the circle's circumference and the circle's radius. So the area of the regular polygon, 1/2 perimeter times apothem, goes closer and closer and closer to the area of the circle, which is then 1/2 the circumference of the circle times the radius. So here we are at the denouement, which is the climax of our story. We have essentially seen from 2 points of view, the geometric and the algebraic point of view lead us to the same conclusion, that the area of the circle is in fact 1/2 the circumference of the circle times the radius. And so my question then is, wait a minute, you don't recognize 1/2 the circumference times the radius? Why don't you recognize that? Well, it's because if you go to Google or you crack open any geometry textbook, you're not going to see the area of a circle being 1/2 the circumference times the radius, even though that's what it is. What we see is a more polished up version, because we know that the circumference of a circle can be represented as 2 times pi times the radius. So what we can do then with that is we can simplify or substitute in 2 pi r in for our circumference, and what we then do is we slowly manipulate our equation into the one we expect. As we see, 1/2 times 2, those are reciprocals of each other. They will reduce to 1. Pi is left over, and then we have our radius times a radius, which is then radius squared. And so there is our familiar form. There is the final result of our area form of a circle. And so I trust that you can use that when you hop over to the 10.9 homework assignment and take a look at the area of a circle. I trust that you can actually take the radius or whatever information is given to you about the circle and calculate the area of the circle. So just keep that in mind, that the homework assignment will be focused on areas of circles. There's also on the homework assignment one other section focused on what we call a circle's sector. It's essentially like a slice of pizza out of the circle. You're going to be using I do an example for you on the homework assignment. So just read through the example, follow through, essentially setting up that the ratio of the arc measure of our circle to the full rotation of the circle is actually equal to the area of the sector to the entire circle. So we get this kind of fundamental proportion that you use. So make sure you just read through the homework assignment. There's one additional section on the homework assignment where you'll be practicing with finding the area of portions of circles, which we call the sectors. So we've come to the end of our lesson 10.9. If you do have any questions on the worksheet or on this lesson, please don't hesitate to email me with that. Be good and do good.